As people continue joining, let me introduce myself. I am Federico Drago from Trust IT Services, and I'm the Blue Cloud Communication Manager. Today, I will be introducing the Blue Cloud project to you and this very interesting application that has been awarded at the Blue Cloud Hackathon this year. So first, I'll just give a brief introduction of the project. Then, as you can see here on the agenda, Bryan Vallejo will introduce the wildlife tracker for oceans. And then Sofia Green is going to explain the use case in the Galapagos Islands. And then we'll close the round of presentations with Tran, who's going to give an introduction of the blue economy model of the wildlife tracker. Then, of course, it will be your turn. So in case you do have any questions for the team, feel free to ask them. And we are going to go over them in the final part of this webinar. If you do have any questions, feel free to use the Q&A function here on Zoom so that then it's easier for the panelists to pick them up or even to reply in typing in case they want to do that during the webinar itself. So let's move on to this first presentation. So I'm just going to introduce the Blue Cloud platform to you so that you understand the context in which this application has been awarded. Blue Cloud is an Horizon 2020 project, and it started almost 3 years ago in 2019. It aims to promote the sharing of data, as you can see, processes and research findings in the marine domain. It is also part of the European Open Science Cloud initiative, and it acts as the marine thematic cloud to this larger ecosystem. It involves 20 partners and a list of data infrastructures, which we are going to see more in details in a minute. These are the main products and services that the Blue Cloud project has developed. As you can see, there is a data discovery and access service, which federates quality data infrastructures from across Europe. We're going to take a look at them in a minute. There's a Blue Cloud virtual research environment in which researchers can come together and perform collaborative research using a series of analytical tools. And it also provides services for the construction, hosting, and operation of virtual labs. Some of these virtual labs have been already created and developed by dedicated teams in the Blue Cloud project, and you can test them already. These are the data infrastructures that have already been federated into Blue Cloud and that are part of the data discovery and access service. As you can see, there are lots of existing initiatives such as Copernicus, Ecotaxa, EMODNet, ENA, EuroArgo, Eurobis, ICOS, CDataNet, and SOCAT. So these are the ones that are already available in the data discovery and access service, which you can find an example of here. This is possible to be tested. So if you want, you can log in with your Marine ID and you can access and retrieve data sets from these providers already and use them for your research. This is the link to the Blue Cloud virtual research environment, which allows you to also using existing IDs, for example, like the IOSC federated ID or EduGain. So it allows you to access these analytical tools and resources that you can then exploit to perform your research. These are the 5 demonstrators which have developed thematic virtual labs within Blue Cloud. Here you can find some examples of the types of data that they use from the data discovery and access service and beyond in order to develop relevant tools and applications and services for marine researchers operating in specific thematic domains. Of course, these slides will be available on the event page after the webinar itself, and you can surely test the thematic virtual labs that you're most interested in. And let's get to the Blue Cloud Hackathon. So we carried this out in February of this year, and more than 100 participants from all over the world took part in it, and 3 teams were awarded for their work, and they were exploiting Blue Cloud resources to make sure that that they could provide feedback and they could test what we were working on. And these are the three teams that have been awarded at the end with the most interesting ideas according to our jury. Today we're going to introduce the wildlife tracker for oceans, which you can see here on the right side of the screen. And at this point, I would like to leave the floor to Bryan Vallejo, who is going to present us this application more in detail. Bryan, it's all for you.
Thank you very much, Federico. That was a nice introduction. Okay, so first of all, thank you everybody for joining. It's nice to see that people is interested in this project. So I'm going to explain how was the process about the hackathon and how we have been working, how we have developed more features for this product. So the name, first of all, the wildlife tracker. To start, I like to explain first what is the wildlife tracker and how it works. The wildlife tracker is simply a cloud geo-framework that works for real-time wildlife monitoring, and it can be used as a personal web app for marine scientists. Specifically, is what we have been targeting these last months. And this is one of the first demos we did after the hackathon. We worked with Azores Islands data, and we chose two specific whales, and we were working with this framework. So this is how it looks. It works in real time, and you can see the animation of the marine wildlife. So we implemented this with MoveBank. So MoveBank is a global database of animal tracking. So it can be accessed with personal credentials, and the same personal credentials are connected to the wildlife tracker. So people doesn't need to create new account in the wildlife tracker or that kind of processes. So they just enter directly to the MoveBank database through the wildlife tracker. And this can be updated at real time so people can follow what's happening with the marine wildlife. As you can see, this is how it looks, the credentials in the wildlife tracker. So then we worked with the idea to implement Blue Cloud. What we did was to implement the global chlorophyll concentration 3D model from Blue Cloud. And we found out that this dataset can be accessed also through Copernicus Marine Service. So once we had this option, not only to use it in virtual lab as a static dataset, we also implemented as an API connection. So we managed to use it in different ways. This is some examples about the virtual lab. As you can see, the virtual lab has a very high power of processing, so you can use it as well for operating the dataset and exploring. I will let you know how we are planning to use it. One of the main benefits of this dataset is that it has historical coverage. We found out that we can access actually since 1998. All right, so what we did is to implement it directly in the visualization framework. As you can see, what you are looking at here is the Blue Cloud chlorophyll concentration overlaid with the marine wildlife tracking data. So users has the option to select the date so they can follow what's actually happening in the migration or in the movement of the marine wildlife. These two black dots that you can see in this demo is representing the last location that was fetched from the database. So normally scientists check every day and looking at when is the last location registered. And yeah, you will listen more applications about it in our pilot demo that we did in Galapagos Islands. So you will listen a bit more in a moment. So once we were digging into Copernicus service, we found out that we can actually add different variables. So we have been adapting more variables depending of the interest of the scientists. For example, this is sea surface temperature. And we can add also pH, oxygen concentration, and more data sets that we are exploring. But at the moment, we have the more interesting for pilot demo, which is for whale shark specifically. So what we have done, we have been working in an alert system that is connected through personal mobile phone. It can be customizable. It depends what the people needs. At the moment, we have adapted to moments when the individuals are out of marine protected area, for example, can be also adapted when they are not giving signals in the last 5 days. You will receive a message from this bot telling you that these individuals are not giving signals. Or when individuals have been found on land, we have also had some accidents about in the last year. We are working in a risk model based on fisheries. So I think the idea of adding more features to this alarm will be something that we are really willing to, because this will be very interesting for wildlife monitoring. We have implemented more features as well. You can download the data. The Earth observation data can be the blue cloud data or the sea surface temperature. And you can also download the map animation. As you saw, it has an animation that you can download it and you can share it through internet. So this is just an example. So the animation is downloaded in a HTML file that can be used as a web map. It has a framework like this one where you can play it or play around with the time frame, and you can create your own galleries. If scientists has studies with different individuals, different dates, they can simply create their own gallery on web. So what is coming next? The main idea is to pack all our algorithms that we have to give usage to the public or to authorities to promote the better marine protected areas management. And what we want to do is to create an installation package of the wildlife tracker that can be used with this historical dataset of blue cloud. As one of the needs that we had, especially with the Galapagos Shark project, is to do research, and they have more than 10 years data of whale sharks, so they need to enrich this data. One algorithm that we have been working the last months is this echo annotation. So you can annotate every location and every date with satellite data, for example, this blue cloud dataset. So we can actually annotate since 1998. But this requires a lot of computational power, as it is very big data. So Blue Cloud can be used, but the first step is to create this installation package where it can be used in virtual apps. So then the product will be a 10 years data of whale shark, annotated with location and time of chlorophyll. So another idea we have, as I mentioned, is to implement more modeling about fishing hours. We had some experiments already how this can be worked, but we are still working in how this model can be created and what this actually can alert. And as you see, we have 3 whale sharks that were found on land in the last year that Sofia is going to explain a bit better. But the main idea is to promote marine spatial planning and marine protected areas management. This is all. If you want to get in touch, please, here's my email. I will be happy to answer any question and anything you need. I invite you to check our website. We have new posts, new blogs. So there is always something new that we are developing in the last months. So thank you very much.
Thank you very much, Bryan. So at this point, I would give the floor to Sofia.
Hi, thank you very much, everyone, for being here, and thank you, Bryan, for that great introduction for the Wildlife Tracker. My name is Sofia Green from the Galapagos Whale Shark Project, and today I'd like to share with you how we've been using the Wildlife Tracker for conservation of whale sharks in the Galapagos Islands. Animals are being tracked through telemetry or satellite tagged all around the world, both terrestrial and marine. We need to do this to be able to better understand these animals, to be able to protect them. Tracks indicate the life history, the movement patterns of hair, which are driving their movements, which we need to understand to be able to protect them.
Sofia.
For their survival.
Sofia, maybe can you try turning off your camera? I think there's some issues with your microphone. Can you maybe turn off your camera? Yeah, thanks.
Can you?
Yes, it's a bit better. Thank you.
How about that? Can you hear me better? Okay,
a bit better, yes.
So so specifically with the Galapagos whale shark project, we've been tracking whale sharks for over a decade, starting in 2011. So we have over 100 whale sharks tagged. Why are we doing this though? Whale sharks were downgraded from vulnerable to endangered by the IUCN Red List in 2016 because of their declining populations. In the past 75 years, we have lost around 50% of our whale shark population due to anthropogenic impacts. So as a project in the Galapagos, we're asking ourselves, how can we protect these animals? And our goals is the long-term whale shark conservation, other marine species conservation which share the same ocean areas, and then using this data for marine protected area expansion and creation of new marine protected areas. Specifically, we've been looking at which factors drive our whale shark movements. With a changing planet like we have right now with climate change, it is essential for us to know which environmental variables are driving their movements so that they were able to adapt marine protected areas to be able to protect highly migratory species such as the whale shark. For this, we're using the wildlife tracker to look at different ecogeographical variables like sea surface temperatures, chlorophyll A concentrations and productivity as proxies for food availability, oxygen levels, currents and eddies, and these are just a few examples of how we're using this. Here in the demo, you can see one of our whale sharks, Sky, moving out of the Galapagos Marine Reserve into the open oceans of the Eastern Tropical Pacific, and we can see exactly what the sea surface temperatures were in her last location. The Galapagos Whale Shark Project began using Wildlife Tracker at the end of 2021. And since then, I have served as an advisor and representation for the needs of scientists. Being a scientist out there right now in the field, tagging these animals and knowing which tools we need to better analyze our data to turn this data into conservation action, I've been able to work directly with Bryan and the Wildlife Tracker to create this innovative tool needed for analysis. For that, we assessed which features were most necessary. And what we realized was we need real-time tracking, being able to see exactly where our animals are when they're moving. But not only that, we like overlaying our animal movements over environmental variables, like the ones mentioned before, also overlaying our tracks over anthropogenic impact detail in a minute. And we need data download. We need to visualize, but extract this to be statistical analysis to turn the data. Also, we have an alarm system that was already talked about. I'm not going to further how we're using it. Here is an example of one of the environmental variables that we've been extracting with BlueCloud and the Copernicus Marine Service. We extracted a proxy for feasibility to analyze whether this was one variable influencing the movement of our whale sharks when left. We have all used Wildlife Tracker for a direct application to predation unfortunate events. 3 of the 8 tags that we placed on our animals ended up reporting on land. Whether the animal was also taken to land with a tag, we will never know. However, we know that there was a definite interaction between our animals and vessels in the ocean. With this alarm system that Bryan mentioned, we were able to create boundaries that would let us know when our whale sharks went in and out of these boundaries. So we created a boundary for the Galapagos Marine Reserve, and we created a boundary for land. So immediately as our whale sharks left the protected waters of the Galapagos Marine Reserve, we were alerted. And if our whale sharks appeared on land, we would also be alerted. And this is exactly what happened. The fact that we were able to find out exactly when it happened allowed us to have immediate action upon this, and we were able to recover 2 of the 3 tags that ended up on land. allowing us to look at special data of highest resolution that has never been seen before. This is also providing us with the opportunity to mitigate this impact. Now that we know that this is a major problem, we're developing workshops to work with the fisheries off of mainland Ecuador and mainland Peru. So here's an example of how we're using anthropogenic impact layers. We're not only using it for the whale sharks we're currently tracking, but we're using historical data to find out how relevant fisheries impact is on our whale shark. And in the future, we expect to not only be looking at fishing pressure as an anthropogenic impact, but we expect to be using it also to analyze variables such as vessel strikes or whale population. At the end of our presentations, I am more than happy to answer any questions you may have about how we're using wildlife tracker in the guide.
Thank you, Sofia. I would like to ask everybody, of course, to add your questions if you do have any questions in the Q&A function here on Zoom. So in case, I don't know, any of the parts that were not clear, maybe for the audio, Sofia maybe can explain in writing in case you have any specific questions for her. And at this point, I'll leave the floor to Tran to explain the future of this application.
Okay, thank you very much. Let me share my screen first. Okay, is this working now?
Yes.
Okay, so hello everybody, I'm James. So next, I will continue by presenting to you the blue economy model of wildlife tracker and also the business model of wildlife tracker. So to start, let's talk a little bit about the blue economy. By definition, it is the sustainable use of the ocean resources for economical development activity while still preserve the ocean ecosystem. However, nowadays, the ocean are overexploited by human activity. That is the reason why we need to transform the ocean economy to the blue economy, with main focus on the marine protected area and marine biodiversity developments, is because the marine protected area nowadays have to improve the marine biodiversity by protecting the endangered species and also ensure the fish stock regeneration. So the protection of marine protected area are very important. Nowadays, the marine protected area are only account for 11% of the ocean coverage. So according to the European Biodiversity Strategy for the Sustainable Blue Economy Development, the marine protected area should expand to 30% by 2030. So these are targets. However, how can we reach this? Due to the lack of the management and also the updated information, it's very hard to expand the marine protected area now with the correct delimitation. So that is the reason why Wildlife Tracker we exist, and we dedicated that we hope to bring the Earth observation data to help expand the knowledge and the data-driven recommendation to expand the marine protected area. So let's talk a little bit about our business model. So the main user of Wildlife Tracker is marine scientists and the marine institution who have the focus on marine protected area assessment, demarcation, and also the wildlife study. One of the examples is the Galapagos whale shark project that Sofia just presented to you just a little bit ago. So this is one of the main clients for us. So by giving our service, we hope to receive some service fee in return, because these marine institution, they often receive the public grant and also some private owner to operate, and they can possibly purchase our service as part of their conservation activity. Another possible client for us can be the ecotourism, like for example, the whale watching. Like we can provide the data about the location of the whale shark, and also the data about the weather, like water quality and the ecosystem to the tourism company, so that they can have a better understanding of the ecosystem, the whale shark, and like prepare the tourism activity for their customer. And we can also receive service fee from that. So from our overall activity, we hope to contribute to the blue economy development by supporting research education, the natural regulation of the whale shark, and also other marine wildlife species for the sustainable growth of the overall ocean. So from the value we created for the ocean, we can contribute to the conservation community, and we hope that we can receive the grant and donation from some NGO and philanthropy that can support us in operating wildlife trackers. Another possible source of support can be the corporate social responsibility, and also some impact funding from the company that they have the operation on the ocean, and they want to gain back the sustainability credits, like for example, the commercial fishing or some transportation company, like when they operate through the ocean, they damage it and they want to gain back credit by supporting us in protecting the ocean. So this is briefly about the wildlife tracker blue economy model. So here is the summaries of our current application of wildlife trackers that Bryan already presented. And in the future, we hope to expand our business by creating more tailor-made geo-framework, and improve our geoinformatics capability. We can add more environmental indicator for the marine scientists. We can also add the wildlife observation function to support the ecotourism. So in the end, we hope that we want to take the best use of the Earth observation data to protect the environment and expand the understanding of the ocean economy and help in marine protected area management and protection of wildlife. Yeah, so this is the end of my presentation. And before we come to the open discussion, we hope to show you our promotion video so that you can see how wildlife tracker operates. Yeah.
Thanks.
Bryan,
so maybe Bryan, you can share your screen.
All right. Just need to be close sharing. Yes.
Discover with us the Wildlife Tracker, a solution dedicated to oceans, and help us to protect the meaningful habitat of marine wildlife. Thanks to geospatial technologies, the Wildlife Tracker can retrieve the location of tagged marine wildlife at the global level. The wildlife movements are displayed in a real-time map animation that supports the daily monitoring of endangered species. Signals are connected to a personal and customizable alert system. The system has integrated ecogeographical layers from Copernicus Marine Service. Variables like the sea surface temperature reveals the suitable habitat conditions of marine wildlife and assess improvements in marine protected areas delimitation. Marine scientists can overlay additional ocean variables to understand the water condition and phytoplankton concentration. The food availability is a factor that drives the pathways of marine wildlife. The Wildlife Tracker is evolving, and now it is designed to annotate ocean variables to the trajectory of marine wildlife, By matching time and location of the tracks, it is possible to create zoning based on ecosystem modeling and promote marine spatial planning. In future development, we plan to include fishing effort indicators from Global Fishing Watch and justify fishery planning based on zones where marine wildlife might be caught accidentally by fishery boats. The system is designed to work globally and can be accessed with personal credentials. The applications are focused in marine spatial planning, wildlife conservation, research, and fishery planning. Users can access and download the ecogeographical layers and create online and interactive map galleries. Be part of this inspiring project and help us to protect marine wildlife and pristine ecosystems.
Okay, thank you very much, Bryan, Bryan and all. This was a really interesting presentation of your efforts. So let's see, in the meantime that probably someone from the audience asks something, I actually had a question. I just wanted to understand if, as of the moment, like aside from these like first test bed, like this use case you're doing in the Galapagos Islands, there's already some work in another specific area anywhere that you're already working on or that you're about to work on?
Well, at the moment, we have been only working with Galapagos Islands. We still haven't been looking too much to find more people that want to use the framework, but we are open to. So if someone wants to use the alarm system, we would be happy to implement it anywhere in the world. As you know, the capabilities are global, so we can just implement it from wherever we are and just provide the alarm system. I would say that we will start to more public once we have defined it at the end of this year, a more packed system that we can simply hand out that say like, hey, please, let's use it, test it. Now it's very easy to access. So I hope we can expand somehow. That's a good idea. So if, Federico, if you have recommendations of people that they want to do it, please send it to us.
Yes, that's something for our audience as well. So if you're here in the audience or if you're watching this webinar afterwards, if you do have any specific requests for the team, feel free to reach out. And then I have another question from a Blue Cloud perspective. So, I mean, of course, you have said that through Blue Cloud, you have managed to access some of these data. And I was just curious about, like, what would you say was the most useful, like, for your work, like that you've managed to get from Blue Cloud directly?
So the main advantage that Blue Cloud data has is the historical review, because the data we have been working is available since 2020, or I'm not even sure if 2019 is available. So when I find out that I have since 1998 Blue Cloud available, so this gives a very historical perspective of all the tracking data that we have been using in Galapagos Islands. So I think also Sofia can expand a bit more about how is this idea going to be used for a research paper that actually she's working. And another thing that I am very willing to explode is the power of the virtual lab, because basically this is a framework that you can leave there running for modeling or something that you need to annotate, and that will be very good. So I am willing to do it, to keep notebooks there. So Blue Cloud is mostly computation and data source.
Thanks. Sofia, did you want to add anything on this?
Absolutely. So we've already been using this in a current study that's being done in the Galapagos Islands. So we hope to have a publication ready by next year, where we're analyzing the entire decade of tracking of whale sharks with the ecogeographical variables. And with the wildlife tracker and the Blue Cloud platform, we're extracting this data to be able to run statistical models, which will allow us to see which variables, ecogeographical variables, are the ones that most influence our whale sharks. And with that information, we will actually be able to see, okay, we need to create marine protected areas that are flexible, not just fixed, that will allow us to make sure that even in a changing planet, we are able to protect our whale sharks. So the value of the data sets is huge.
Thank you. That was very clear. There's another question here in the Q&A. So Juan Miguel Villoria Serrano is asking, can you please explain how is the infrastructure of the wildlife tracker implemented on Blue Cloud? So I don't know who wants to pick this up, maybe Bryan or...
Yeah, I can actually show a quick picture. So should be now on the screen, right? So, well, the question is saying that how we implemented the wildlife tracker on Blue Cloud. I'm not sure if that's the way to say it. Probably it's the other way around. They are actually a mix of connections, but wildlife tracker, I'm sorry, Blue Cloud, what provides is a model that can give chlorophyll concentration at global level. So what this model is actually implemented in the cloud of Copernicus Marine Service, and it keeps available this model already implemented since 1998, as I was mentioning. So the wildlife tracker has a script that connects through API until Copernicus Marine Service and fetch the data that we want. The data is directly from the Blue Cloud model, and it can be fetched from the year, the month, the week we want, as this one here. So marine scientists normally check if they are in January moving to the north, so they check like maybe there is a reason of chlorophyll concentration that they are willing to find, or how this affects the movements. So normally this is how it is used and how it has been implemented in this backend of the wildlife tracker. I hope the answer is good, and if there is more doubts, don't hesitate to ask. I would be happy to explain or to ask. I'm sorry, to reply.
Thanks. There is another question in the chat from Selima Ben Mustafa. So she's asking, the pilot area is the best example, but can we replicate this methodology in other areas, such as the St. Lawrence River for beluga whales? In the Baltic Sea, there is a case of waters that make it difficult to identify chlorophyll from Sentinel-3 data. Is there any ongoing research for improving and promoting the blue economy in the near future? I mean, I think it links to my previous question, but I don't know if you want to expand.
Yeah, so I think I will reply the first part. So, well, yeah, Galapagos has a lot of wildlife for doing this kind of research. And about replication, yes, we can do it. And it's actually very easy because our database is globally covered already with Argos satellite. So if you have already tagged beluga whales, then the only thing we need is to be part of this study in MoveBank, and we give you access to the wildlife tracker. So it normally takes 1 hour of configuration, and then every scientist can access to this in real time, as we mentioned. So the replication is actually quite easy because the API connection as well, it is not designed only for Galapagos Islands. It's designed for the data of wildlife tracking that is fetched. So if you have beluga whales in the north, you simply the satellite data is going to display in the same area. So it's an adaptive script that it's working at global level. And then, yeah, I know that from Sentinel-3 it's difficult to catch some CHL, but as I understand, in the Baltic Sea there is already a lot of data set that has implemented a lot of variables. I think if they are available in Copernicus Marine Service catalog, we can just adapt this new data set. This is what I would recommend because we don't have only Blue Cloud chlorophyll, we have all the catalog that Copernicus Marine Service has. So we can add more things, we can implement a lot of things there, and that would be very interesting actually for beluga whales. So about the blue economy, maybe Chan also can add here, but I think that one of the most important things we want to do is to create a coastal resilience between wildlife and fisheries, because based on these accidents that we had, we want to create a protection for wildlife, but we cannot stop fishing because coastal communities lives from that. So there should be a balance, and the wildlife tracker is something in the middle that can prevent the accident with wildlife and also to keep a good scheduling of coastal fisheries. So this is something that will require more time, and also Sophie, welcome to reply if they have something to add.
Yeah, about the ongoing research about blue economy, I think it is like more research are being conducted on the like marine protected area spatial planning, like, but it's about government work, and like they will do a lot of research in order to expand the marine protected area, because the target is 30%. And our work here is that we hope to support that, and we hope to contribute to the research with government by like providing the information to the scientists, and the scientists, they can after that recommend to the government.
Perfect, thanks. So I don't know if there's any other question from the audience. I think we have probably answered them all. Yeah, I see that Selima said thanks in the chat, so I guess that was a satisfactory answer. Okay, I don't know if you guys had any other final remarks you wanted to add before I wrap up the webinar.
Well, what I can say is thank you, Blue Cloud, because starting from this hackathon, we had a lot of ideas, a lot of process happening here, and this has been very exciting, very inspiring as well. So let's keep going with this to see how things go, and please don't hesitate to contact if you have any doubt for everybody.
Thanks, Bryan. It's really useful for us as well to get this kind of feedback from researchers which are using the Blue Cloud services. And well, before we close, I'd just like to remind everybody that Blue Cloud is holding its final conference in Brussels on the 8th of December. And actually, representatives from the Marine Wildlife Tracker will be there as well. So in case you want to join us in December, feel free to visit our website, complete the registration form, and meet us in Brussels in a couple of months. So we are going to wrap up this project and then move forward for the next leg of the enhancements of the services that we have developed in these first 3 years. So with this, I thank everybody, and I'll see you at the next Blue Cloud event. Wish everybody a nice afternoon or evening or morning, depending on where you are in the world. And thanks, everyone.